Welcome to the next session. We're excited to have our friends at KLJ leading a session on project life cycles and creative project solutions. Enjoy.
All right. Good afternoon, everybody. Happy Tuesday afternoon. And I want to just start off by saying thanks for inviting us to present at the conference. Before we get going on our presentation, we'd like to do some self-introduction. I'm Tom Nygum. I've been in the aviation industry for about 26 years now, and I truly enjoy it immensely and look forward to the presentation here. Shane?
Hey, my name is Shane Steiner. I am the Aviation Department Manager with KLJ. I primarily work with our airports in Western North Dakota. I've been with KLJ for 14 years, and I am out of our Bismarck office.
I'm Matt Nesbitt, Aviation Planner out of our Bismarck office, and I've been with KLJ for about 10 years.
All right, thanks. We've got a kind of a dual-fold presentation for you this afternoon. The first one we want to start off with is just talking about the life cycle of a project. I'd like to give Matt Raminzi a shout out on this one. He thought it would be a good topic, and when he offered it up, I thought it would be a good one as well. So we'll be talking about that first, and then our second part of our presentation is talking about some creative project and engineering solutions. So to start out with, on the project life cycle, I just wanted to caveat this. I know the FAA has, in the past, has come out. They've got a project life cycle. I think it's an 11 by 17. It's like 3 pages long. It's all encompassing. But what we wanted to do for the airport sponsors out there is really distill it down into some of the bigger key items on projects, especially those standard design. You start out with the project, you design, construct it, and you close it out. So that's what we wanted to do with this presentation is cover that. So, with this project, if you have more complex projects with the project life cycle, there's certainly going to be more steps involved. You could be involved with FAA tech ops. You could, have flight checks, reimbursable agreements. There's all kinds of other things that could be in a project life cycle. So don't take this as all encompassing, but we wanted to kind of walk through for the airport sponsors out there, just to, kind of the bigger picture on a standard project, what it looks like. So with a project life cycle, really it's starting out with the project initiation, moving on to the FAA grant pre-application, then you develop your consultant contract, perform your field studies that are necessary, design the project, bid the project, obtain funding, construct the project, and then ultimately close the project out and start the cycle over with your next project. So with the project initiation, really what you're going to see is State Aeronautics will typically reach out to airport sponsors starting in the summertime and set up those summer and fall meetings with the FAA and State Aeronautics staff. And really what it's meant for is to get together and go over your projects. So you'll look at your capital improvement plan development. With that, you're looking at the CIP in the short term, that's 1 to 3 years out, and then also the long term too. But really the focus of the project initiation is going to be, distilling that and drilling it down into what you're going to do next year's for a project. And you want to have good preliminary cost estimates to those projects, in particular the ones that are probably 1 to 3 years out. And then we're going to talk about available funding sources for all your upcoming projects, especially the one a year out. Make sure that it's looking like that's a green flag to go, and you'll be able to complete that project in this fiscal year. And then as an airport sponsor, one thing you'll always want to check, it's got to be done annually, is check your system for award management expiration date, your SAMS number, and make sure that's still applicable, because you don't want that to expire, and that's got to be on part of the paperwork when you're moving forward with your project. The second thing is develop the FAA grant pre-application. So this is your pre-grant paperwork to give the FAA formal paperwork that says this is what we're going to do this year. That will follow after your initial meeting, your project initiation meeting with the state and the FAA. Typically, that's going to be due to State Aeronautics in mid-October. So you can expect that that'll be due about then. I believe the FAA has them due sometime the beginning to mid-December is when they're due. So the state will actually take them, compile them, and start looking at them and planning for the funding of all the state projects, and then ultimately turning them over to the FAA in December when they're due. And this is the time you're really committing to the project you're going to be completing for this fiscal year. So you're really putting the pen to the paper and saying, this is what we're going to do. The next thing you're going to want to do is develop the consultant contract. First, that starts, excuse me, that's going to start out with development of the scope of work. So your consultant's going to develop the scope of work, and then once they've got that completed and have a good understanding of what the project is, they'll be meeting with you as the airport sponsors to go over the scope of work. And really what the scope of work does is it sets the table for what the consultant's going to be doing, outlines the tasks that are going to be completed, the project, and really starts defining that level of effort that's going to be included in the consultant contract. Once the sponsors reviewed that and approved of it, the next step will be to send that to the FAA for review and approval. And so you want to get this to the FAA well in advance of getting the contract done. Depending on the project, the FAA review could take a couple days, or it could take a couple weeks or longer, depending on the complexity. So we usually get those in. The FAA provides comments back. And then once we get those comments back, what we do is we work with the airport sponsor and the FAA to iron out any differences, make sure everybody understands what that level of effort is going to be for that project, and really agree to the scope of work. Once that's done, the next step will be moved to an independent fee estimate. So what that is the airport sponsor for projects where the fees are over $100,000 in value. The airport sponsor will go out and get an independent consultant, somebody that didn't try for the 5-year selection for your airport, to give an independent fee estimate of what it really takes. So what the sponsor typically provides to those consultants is the approved scope of work. A lot of times it'll be the Excel file where that independent fee estimate consultant can enter their hours, their estimated hours for the project, and then a cost estimate. And so they can see what the project entails. Probably a sketch too is a good thing to send to them, so they have a good understanding of what the project really is and the order of magnitude. Once the independent fee estimate comes back to the sponsor, the next step will be for the airport or the sponsor's consultant to send their fee estimate to the sponsor. Then what the sponsor does is they take the independent fee estimate over here, and they take the their consultant's agreement or fee estimate, and then they look at those and compare them. And really what you're looking for is an apples to apples comparison to make sure that everybody's on the same page. So as an example, if there's a disparity in the costs or the level of effort, sometimes you can look and see, well, this task is the independent fee estimate has 4 hours, where the consultant doing the work has 40 hours. So, you know, the difference is pretty large. So you can see there's probably a misunderstanding of what that task really means. So sometimes there's going to be a handful of those to iron out as the sponsor looks through the independent fee estimate and compares the two. And you know, when you're comparing the two, the FA's rule of thumb is determination of reasonableness is if the two are within 10% of each other. Excuse me. So when you're looking at those, like I said, the FA is looking for 10%, within 10% is reasonable. And if they're outside of that 10%, then the sponsor and the consultant negotiate until they've reached an agreement. And then once they've reached an agreement, they would then enter into a contract to do the work. Once the contract's in place, then one of the first things we want to do right out of the chute is complete the field studies. I've listed a few here that typically come up: topographic survey, geotechnical evaluation, and then environmental field studies that need to be done, to name a few. So with the topographic survey, really what this consultant's trying to do is gather the survey data for the area that the design is going to occur, if they haven't done so already. So they'll want to get out there and get that surveyed as soon as they can in the fall, and really try to get that completed before the snow's on the ground. Much easier to pick up inlets and manholes and, you know, some of the infrastructure that's really flat on the ground if there's no snow on the ground. So we want to get going on that. At the same time, there's probably going to be a geotechnical evaluation that needs to be done. That's where the consultant's looking for information. If it's a paving project, if it's existing paving, they're going to pop some holes through the pavement and determine how thick the pavement is, how thick the base is, you know, what's underneath it as far as soils, in order to do the pavement evaluation. For buildings and fuel systems, there could be foundations that need to be installed. So there we may need to do a deeper investigation. It really depends on the project. And really it's to find out what's there so that we can make, the consultant can make an adequate design. And then on the environmental side, really there's wetland delineations that need to be done at times. Those need to be completed during the growing season. And typically the FA is going to define the growing season as mid-May through probably the end of September. So it's really when you can see that the growth that's attributed to wetlands versus not attributed to wetlands. So those have to be completed during the growing season. So it's important to get those done in the fall as soon as possible. There's also the cultural walkthrough where we're looking, the archaeologists, and sometimes there's the tribal aspect of it too, where they're actually looking for those cultural features on the ground. So they're actually walking around looking for cultural features. So that has to be done without snow on the ground. So they have an unobstructed view of the ground, of the area where we're possibly going to be doing the construction, borrow and waste areas, those type of things. And then if you have buildings, if you're going to be doing anything with a building, including demolition, probably going to have to take a look at doing a hazardous material inspection where you're going to look for asbestos, any of those type of things in the building. And if the building's approaching or older than 50 years, you may have to do a historical preservation investigation of that to see if there's any historical significance to that building. And so once you've wrapped all this up, then we're looking at the environmental determination. Typically on most projects, what you're going to see is a CADX. Hopefully that's what you have on the project. If it's anything more than that, such as an environmental assessment, or above that would be an environmental impact statement. Those are really standalone projects. So really what I'm talking about here is the CADX version, where we submit something to the FAA that's fairly um, uh, less complex to complete, takes a little bit less time, and then get the FAA approval on those.
All right, thanks, Tom. Well, now that we got through the environmental and the planning, we get to go into the fun part of the project, right? Which is the design. So kind of the important things to kind of from the owner perspective or the sponsor perspective is some of the main meetings that we have during the project. Now, these aren't all the all-inclusive projects, and not to be a death by meetings, but these are kind of the high-level highlight meetings that that we wanted to focus on. They're kind of important for really any project. If you have a more complex project, there's going to be more, obviously. If it's a more simple project, there'll be less. So, but these are kind of the ones that I wanted to talk to everybody today, and for that kind of high level 10,000 foot overview. So the first is a pre-design meeting. So what does that entail? So that's more for your consultants to kind of take a look at that 10,000 foot overview. What's the purpose of the project? What is the schedule of the project? What is the point that we need to achieve here? So from then we go into the preliminary concept meeting, and that's really where we take that data that we mine from our internal pre-design meeting, and we meet with really all the stakeholders involved with the project. So we're meeting not only with the sponsor, but with the agency. So the FAA, the state agencies, any local agencies that will be affected, whether that's the control tower, any major utility companies that are going to be infected, any other like local stakeholders that have an impact from the project. So again, we kind of look at that 10,000 foot overview, and that's kind of really where everybody throws all the cards on the table, where everybody has something important that they want to achieve out of the project. So while the air traffic control tower might want to see one thing, it might not be the same thing as the FBO wants to see. So getting everybody's perspective is really important going in, because we don't want, as your consultant, to go into a design and start going down the wrong path. We want to make sure that we're going in the direction that everybody wants to go. So it saves money for the project, and it saves time for the consultant. The next we have is the preliminary design engineer. So really we take the information for those first two meetings, kind of combine them, we start going into the design. So then we are adhering to the FAA, your design standards, any advisory circulars we need to adhere to, and start going and kind of doing that deep dive, formulating the project, the plans, and the specifications. So the preliminary design meeting is really when everybody comes back to the table, and usually as your consultant, we're going to say, okay, well here's what we find, and any consultant out there I think can agree where there's always one uh-oh moment or an oops, we might have misplaced that information. It's a bogus survey shot, or a utility that magically went from abandoned to active. So that's kind of when we come back to the table and take a look at and get everybody on the same table or on the same page as far as here's what's really going on. Here's the one or two things that might have popped up from that preliminary concept meeting that could potentially delay the project, or extra communication or coordination. Kind of getting everybody back on the same page. So then after that, really, then that's kind of the home stretch, right? So kind of see the light at the end of the tunnel for that final design. So with that final design meetings, we take everything from the concept meeting to the preliminary design, everything from the stakeholders. So hopefully that final meeting, it just kind of the frosting on the cake, so to speak. So everything is involved, and everything is nearly about that 90% complete. So any last minute quirks or anything can kind of come up at that final meeting, and from then we can finalize the plans and the specifications. I'm going to go to the next slide, Tom. So kind of the few other things for the design that that we wanted to hit are kind of the milestones, more so for the consultant that goes into design. So the first thing is the engineering design report, and not to get all nerdy on everybody, but it's kind of the sexy part of the design, so to speak. So with the engineering design report, we get to accumulate all that information from that from the meetings. We get to dive into the alternatives. We're taking a look at the hydrology. What is the storm sewer, sanitary, any utilities affected? How is that going to play in any utilities other than airfield utilities that are affected? Kind of throwing everything into the cake batter, mixing it all together, and kind of putting it out. So that's kind of the exciting part of the project for the engineer. And I can't see, but I can tell that everybody else is would agree with me on that part. So so after that, and it's important to lock down, or at least get the final draft of the engineering design report to your FAA program manager early on in the process, because there's always something there's always something that comes up that either wasn't foreseen by the consultant, or perhaps by the FAA. Perhaps an advisory circular is on draft, an updated copy is coming out, so maybe there's information that's coming down the pipe that we haven't considered, that the FAA has internal knowledge of, that would be a good time to share that. So and again, we use that engineering design report to finalize your design as well. So then the next part is the construction safety plan. So that needs to be submitted through the OE-AAA website, which I'm sure a lot of you are familiar with. So, and the FAA does have a handy SOP for the submission of your construction safety plan. And what the safety plan is, it's not only for before it was always kind of thought of as an airspace case, where looking at pieces of equipment, the cranes, to see if that would violate any part of the airport where there was going to be active aircraft. Well, now it's more looked at the planning part of the project, where the points of interest are submitted. So then the FAA and the sponsor can see where the haul routes are going to be, where the staging and storage area is going to be, any borrow or waste areas, and are those areas the same thing that are on your environmental documents? As many of you know, it's pretty important that whatever we put on the plans and specs follows the environmental documents that were preceded by that. So keeping up with that same consistency is important as part of that construction safety phasing plan submission as well. So then now that we're getting into the home stretch, where it's time to submit the final plans and specs to the FAA for review and comment. Typically, the FAA is going to ask for these roughly 60 days before the advertising of the project, and this gives them time to do that review. So depending on the project, again, it could be a full review, or it could be a smaller scale review, depending on your project. But getting the plans and the specs to your FAA program manager, again, is just going to allow that time frame, just in case there's some last minute tweaks that need to happen. That way, not everybody's scrambling and sweating at the 11th hour to make sure we meet our grant application deadline. So. And then the final part is the finalize the plans and the specs, which is really the stamping the plans and the specs. So as a consultant, we like to get those buttoned up and ready to go as soon as possible. So as soon as we get the green light from the sponsor or the FAA, those are ready to go. So now we're at the point to bid the project. So with bidding the project, we need first to advertise for the bids. Each a little bit different. So just a note to check your local state century code and what those requirements are. The first part of the after the project is bid is what we like to do is set up a pre-bid meeting. Now, it's not required for all projects. Kind of goes back to the scale of the project. If it's a large project, it's encouraged. If it's a smaller project, like say a seal coat, crack seal, pavement markings, probably not going to be worthwhile to do the pre-bid meeting. And the contractors bidding on those projects are pretty specialized and have worked on airports before, so probably not worth the time and the energy for those. But for the more complex projects, especially where safety is a concern, they are a pretty good idea. And some of the things that we like to go over in those meetings include bidding requirements, Buy American, DBE requirement, your federal or Davis-Bacon wage rates, project safety, and project timeline. So what this does is also gives contractors who may not be as familiar with work or working on airport projects to kind of give them the kind of the overview of what's required and kind of get everybody on the same page. That way, it never fails that after a project is bid or once the construction starts, there's always that minor detail or maybe that footnote that that dang engineer put at the bottom of the plan page with the size 2 font that nobody saw. So this is really the opportunity to make sure that the contractor knows really what they're getting into and any specifics. So after that, we hold the bid opening. And after the bid opening, as a consultant and working together with the sponsor and the sponsor's attorney, we review the low bidder's proposal for accuracy and completeness. And a couple of the main things that we look for those as we're evaluating those is the DBE evaluation. If the project is valued at over $250,000, DBE commitments are required. So did the contractor put good faith efforts towards meeting those goals, or if they did say they're going to reach those goals, are those legit basically? The other thing is the Buy American certificate evaluation, and that may need the sponsor's attorney's advice if any issues come up. So those are kind of the two main things that from the consultant side that we look for after we open bids. After that, we take a look at all the information, and then we do make the recommendation of award to the sponsor for the low bidder that meets the requirements. So that's kind of the important part of that is that a low bidder that meets all the requirements of the project. So after that, now it's time to get money. I'll let Tom take over how you can arm wrestle your state and federal officials to get them to dump back up that Brinks truck.
Thanks, Shane. I can honestly say I've never heard the engineering design report called sexy before. All right. So then we move on. So now you have you've got bids in hand, so you know the actual cost of your project. You've got your consultants agreement in place, testing and things like that. So now you know the actual cost of the project. So what the FAA is going to ask you to do is submit a summary of costs to them and the state as well. And so you'll submit the FAA grant application based on the costs as bid, and then the state grant application as well. This really holds true for with the state. Sometimes, or most of the times, we have projects bid before their June state grant meeting. Some of the discretionary projects we won't. So a lot of times what the sponsors do, they'll put in an application, a state grant application based on estimates, and then following up the next year, if there's money to turn back, you turn it back when we're closing it out, or if you need more, you can request more from them at that time, a supplemental. And then once you receive the FAA grant agreement, execute that. Believe those are electronic now. So you'll be executing that electronically. That does involve your attorney's review and signature as well. And then award the project once funding is secured. So once we have that in place, we'll award the project to the contractor and then proceed with construction. So we've got everything in place now. So now, as Shane said, we to do death by meetings, but certainly once you get to construction, there's important meetings as well. The first one you'll want to do is hold the pre-construction meeting with the low bidder. And so we'll be meeting with them to talk about many things on the project. So again, you go over some of the things that you did in the pre-bid meeting if you had that, talking about safety, talk about security requirements, any security requirements, going over the project as a whole, just talking about submittals and all the things that the contractor is going to need to work on, mixed designs and things like that. And really that meeting is to set expectations and help define expectations for the contractor. So it's really a good opportunity for everybody to get on the same page and make sure that everybody is on the same page so we're marching in the same direction. And then as construction progresses, it's a good idea to hold weekly progress meetings on most projects. Certainly if you have small projects, crack sealing and things, maybe it's not necessary, or maybe you're only going to have one anyway or two. But certainly for most projects, it's a really good idea to have those weekly construction meetings. Again, those meetings are really, the focus is to talk about safety, talk about security, talk about submittals, what's due, what does a contractor have left to complete as far as submittals, talk about a summary of what the contractor's doing this week, what do they plan to do next week. And really it's, again, getting everybody on the same page. So if something's coming up, say there's a phase change or anything like that, it's really talking about that so the contractor and the airport sponsor are aware if there's NOTAMs to be issued or things like that, everybody's on the same page. And then weekly FAA reports. The FAA requires weekly progress reports to be filled out and completed. And those reports do a lot of the same things that the weekly meetings do. It's summarizing what's done this week, what's going to happen next week. It summarizes who's on the project, the time charges for the project, the weather, which is really important when you're documenting the weather for the project, including precipitation to see when the contractor was working and when they couldn't work due to rain delays or things like that. So then you get through construction, and then you hold a final inspection on once the project's completed, and then develop a punch list of construction items and paperwork that the contractor has to complete. Excuse me. And really send them that summary so they're aware of what remains to be completed. And then once that's completed, the punch list items are completed, you can process the final payment to the contractor. Once that's completed, you submit the closeout report. So there's a lot of things that go into the closeout report. It's really a financially summary of the project. It'll include all the approved agreements with your consultant, with the contractors, things like that, testing summaries, and then some things you may have to complete as part of your project is an airport layout plan update, if it's required, and an Exhibit A property map if there was anything impacted on your property side. So the picture on the right there is one of the young KLJ engineers at the time. This was actually a summary, or it was actually the testing reports from the first phase of the runway on the Bismarck runway project. So I think this was like a 7-inch or 6-inch binder. So again, that was just the testing for the project. So lots and lots and lots of paperwork when it comes to federal projects. So that concludes the part A of our presentation. And I guess we'll stop at this point to see if there's any questions. All right. Hearing none, move on to the second piece of our presentation, creative engineering and product solutions. So what we're going to talk about here is I've got a few that I wanted to talk about where we've done recently in the last few years at the Bismarck Airport. And then I'm going to turn it over to Matt and Shane to talk about some of what KLJ did at the Watford City Airport. So the first one I wanted to talk about is the Bismarck Airport and the phasing of the runway. Really, when we started this project, it was started in the I think it was started about in 2011, where we did some investigation on the runway, turned into some patching in 2014. But really, we were working on the engineering design report. I believe it was the end of 2016 when we showed up for a meeting with the FAA, who said, "Oh, by the way, we've got funding a year early, so can you guys get this ready to bid in May and June of this coming year?" And that was a little bit of a surprise to us because a project of this magnitude, especially when you're talking about impacting FAA navigational aids on a commercial service airport, takes a substantial amount of time to plan and move through those efforts. So, but we got it done. And really part of one of the biggest things we had to do as part of that project is really how to decide to phase it. Because really we had some limitations there. Number one, we had funding limitations set forth by the FAA, who came to the meeting and said, "You're really going to get funding over a 3-year window, so plan accordingly." That combined with FAA design requirements, so working on runways, there's specific things that can and cannot be done. Like as an example, the first and last quarter of your runway cannot have a vertical curve or a change in slope. So, really once you set the profile of that runway, you have to figure out how you're going to make it work. Luckily in Bismarck, we had a couple, we could divide it up into 3 areas, which I'll show you in a minute here. But one of the main things we did and really stressed was minimizing operational impacts to the airport users. So the existing tenants of the airport, and then of course the airlines, very important to maintain air traffic into the Bismarck Airport while we did the runway construction. And I have to give a shout out and kudos to the Bismarck Airport staff, Greg, Tim, and everybody who worked really hard on this with us and kept the airlines well informed, because airlines switch up. You need to coordinate probably 6 months in advance with airlines with their aircraft fleet mix, so that they're bringing in the appropriate sized aircraft and not something that can't land at the airport. So that was really important when we went through this. So the first phase, the first phase actually had 6 phases to minimize operational impacts to the airport users. And, when you have phases within a phase and you're trying to get things done, it really tends to complicate things. But with good planning and, working with hand in hand with the contractor in the airport, in the FAA, it was very successful. So the first phase, what you're looking at here, red means closed and green means open. So the first phase, actually what we did is we were working on an area north of the crosswind and the main runway 1331 and runway 321. We're working on the north and south side of that. So essentially we were staying away from the runway intersection to keep crosswind runway 321 open. Crosswind runway 321 is 6,600 feet long by 100 feet wide. And then the main runway, we had 5,450 feet by 150 feet available. So again, during this phase, we could accommodate the airlines with their aircraft fleet mix changed up to get in and out of the Bismarck Airport. We then moved into the second phase where we actually tore into the runway intersection. We added a little bit of length during 1B to runway 1331. That was actually 3,600 feet long instead of 5,450, but as you can see, it was the only runway in town, so it had to work for everybody at that point. and then everything south of the relocated runway 3-1 threshold was closed along with the crosswind. And then phase 1C, we actually lengthened runway 1331 a bit more, got 7,050 feet out of it, usable. And at this point, we had the runway intersection completed so we could reopen crosswind runway 321. So all these phase switches, they had to be done expeditiously so we could get all this construction done and completed in one construction season in North Dakota, which, as everybody on this phone is aware, can be very challenging. And then phases 1D, E, and F, I don't have sketches for those, but really what those were is to allow the runways to be open, and there was grooving of both runway 1331 and runway 321 at night, and then there was painting that could be done during the day and between flights with prior permissions required. So very challenging to do, to complete, but a very successful project. And then just for everybody's information, just wanted to show you 2018, we reconstructed 5,500 feet of the main runway. So runway 1331 was closed completely during the construction of this, and only runway 321, again, 6,600 feet, was open at the time. And then in 2019, we just had the north 1,100 feet plus the connecting taxiways and a taxiway Bravo to complete. So that was really the wrap of that project. So lots and lots of effort. The engineering part was probably the easiest part of it. It was really the coordination, the phasing and the planning of each phase, and trying to match that up with what funding was available each year was the biggest challenge. Okay, second piece I wanted to talk about is the runway 1331 pavement design. So really with Bismarck's pavement, we were trying to do limited frost protection, which is basically 65% of the frost depth at the Bismarck Airport. So frost depth is about 6 feet. So 65% of that, we were trying to get a pavement section that is 47 inches in depth. So when you're digging a pavement section in that's essentially 4 feet deep, it can be problematic, especially if you have a high groundwater table. The picture you're looking at there was actually a picture during construction as the contractor was excavating on the far south end of the airfield. That water you're seeing is not from a rain, that is groundwater. So contractor got down 4 feet and we had the groundwater, we were in the water table. So, we assumed that was going to be the case when we designed the runway. So we had to look at how are we going to do this. Really a typical FAA project. They want that bottom 12 inches of soil to be scarified, moisture conditioned, and recompacted. We had anticipated that was going to be an issue on the Bismarck Airport and was going to cause issues. So we had to come up with a different way to stabilize the subgrade before we built the pavement section. So we were working with our geotechnical consultant, and knowing that we were going to have issues with the groundwater, they did not recommend any what we call chemical stabilization, which is really mixing cement or lime or something like that into the dirt to make it stronger, just because of the potential for the groundwater. It wasn't going to work. So what did we do? So what we did is we had about, rough numbers, we had about 80,000 cubic yards of asphalt millings that was coming off runway 1331, and thought it would be a really good idea to reutilize that material. So what we did is the bottom layer, instead of going down 47 inches, we went down 59 inches. So essentially 5 feet in the ground. We started with a material called GeoGrid. And then on top of the geogrid, we actually put a foot or 12-inch thick millings. So instead of doing the scarify, moisture condition, and recompaction of that 12 inches, we actually used the millings to stabilize that area. And then what we did in that millings is we actually installed edge drains in the millings, because the millings are fairly clean. The water gets through it. And then on top of that, we actually had a fabric, a separation geotextile fabric, followed by 17 inches of subbase. We had 8 inches of P209 crushed aggregate base course, 6 inches of cement treated base, and then the icing on the cake was the 16 inches of concrete. And there you can see a photo of Troy Estes, the Bismarck Airport maintenance supervisor, holding a test tube, if you will, of cores from the runway. So that's actually what you're seeing him holding up and smiling alongside is actually the pavement section for the Bismarck Airport runway 1331. And once we got to construction, just a side note, the contractor that did the first two phases of the runway, especially when we did the first phase on the south end, he said that was like, he said if we didn't use the millings in the way we did to help stabilize it so they could more efficiently construct the runway, he said they would have been in trouble. And he actually said they don't know if they would have been successful getting the first phase of the runway completed in the allotted time. So they were very, very happy that we had gone that route and sought the FAA approval to utilize the millings to start out as the foundation really to build the runway upon. And the last thing I want to talk about on Bismarck is wetland removal projects. And so what you're looking at the screen, all the red areas are actually wetlands that were delineated and identified on the Bismarck Airport. So where we're at today is phase one. You can see identified there, that's actually been completed. Phase two has also been completed, the construction of that. And what we did as part of that, we had but phase three, that's one we're working on now through the center field of the airport. Seems like there's, don't know why, but there's lots of wetlands off the end of the runways. So we're trying to minimize those. The airport did a environmental assessment, which involved a wildlife hazard study. The wildlife hazard study basically said you need to get rid of these wetlands, and then the EA was the environmental assessment was the tool to allow the airport to get rid of the wetlands. And like I said, we're working on phase three. That's being done in a phased approach because of the cost, but we're currently under construction right now on that. So with the wetland removal projects, one of the things we did is we were trying to figure out how to get these flat areas to drain. So essentially the airport's really, really flat. So to build ditches out there and hope that they drain is very challenging. The airport's done that in past year. And what happens is those ditches eventually, because they are so flat, they do fill in again with sediment, and then they start holding water. And then what happens? The cattails in the wetland starts to come back again. So really what we looked at is how do we permanently eliminate those wetlands? And so one of the things we found and tried on the first projects and was very successful was instead of trying to just do a regular ditch, we actually put a ditch in with cable concrete. As you can see in the photo there's one of the ones that's nearly finished. And so that cable concrete it serves twofold. Number one, it's really providing erosion control for that ditch during high flow conditions. But the second thing it does is it allows the Bismarck Airport maintenance staff to jump in a tractor or a piece of maintenance equipment and drive down through that ditch. And so they can get down in that ditch, and if they need to spray for weeds or do whatever they need to clean out sediment, they can do that, and they can do that effectively. And so that it serves as that stable platform for that equipment to drive upon. And then on the lower right-hand corner of the slide there, you can see what the section looks like. So basically, underneath this cable concrete, what exists is there's actually aggregate. So it's a clean aggregate. The FA calls it porous material number 2, about 20 inches in thickness. And then contained within that, there's actually 4 6-inch perforated drain tile pipe. So what happens is in the larger flows, of course, the water fills up in these areas and kind of whooshes through over the top of the cable concrete, and the cable concrete helps the hold these areas so that there's no erosion. But the second thing is the subsurface drainage, where these pipe and this aggregate actually serves as like wicking effect. So in these areas where we do have high groundwater, as we talked about earlier on the runway, we can actually wick the moisture and the subsurface drainage out of there. So while it looks dry on top, typically what's happening underneath here is there's water still running through these under drains or these drain tiles. And we've got areas on the airport that, the area we're looking at is off the east side of runway 21. This actually does a gravity flow where it drains out into, ultimately gets into Apple Creek. We just did one on the northwest side of the airport, just completed it this past year, where in order to drain it, we had to install a small lift station to pump the water out of the ground. But again, we're trying to get rid of the wetlands, so try to do what we can to get rid of them. And so what you'll see is there was an area up in here where there was a tremendous amount of meandering oxbows and things like that. And what happened was all those were eliminated with this drainage project. There was all kinds of meandering oxbows through here and here. And after we got done with that, you can see that the airport can very easily come out here and mow and maintain it. And same thing with this area. So with that, I'll pause for any questions.
We have no questions at this time.
Thank you. I'll turn it over to Shane and Matt to talk about Watford City.
All right, thanks, Tom. So what Matt and I wanted to chat with you today, as far as kind of relevant projects, is Watford City. So Watford City is kind of a special project, one of my favorite projects that I've worked on in my career, and it's literally a project that's been 12 years in the making, going all the way back to an ALP update in 2008, before the oil boom, and then obviously going through the oil boom, and then to construction finally commencing last year. And construction, knock on wood, wrapping up this year. So the kind of the highlights that we wanted to hit with the project that we thought would be interesting for everybody to kind of hear is to kind of go through the project history and the different alternative analysis that we did. There was multiple and some unique ones, especially for general aviation airports. So Matt will take you through those. And then I'll come back and circle around with what the funding scheme looked like, some of the design challenges that were met with the project, and finally some the construction progress to date, and how we look for wrapping up the project. So I will now hand it over to Matt, our expert planner for the project, who literally put blood, sweat, and tears into the project.
Well, thanks, Shane. And Tom, go ahead and pop over to the next slide. And I will take us back in a time machine to Watford City 2007. The prior master plan study was just getting going. The oil boom was not occurring yet. The airport had a 4,400 by 75 foot runway, what they have prior to construction going on right now. And in that initial master plan study, it was more of a challenge to hang on to that 4,400 feet. There were some design standard things that the airport was working through, and chopping off the runway would have been an easy fix, but they made it through with that runway length. Then it served the aircraft they had operating there well. Really, at that point, it was mostly all small aircraft under 12,500 pounds. So another way to look at it is anything King Air 200 size or smaller was kind of the primary users of the airport at that point in time. And Tom, if you want to go to the next slide. Okay, so we fast forward a couple years and the Bakken starts to heat up. There's starting to be a lot more justification for a longer runway. You have larger aircraft operating out of the airport, coming into the airport. King Air 350, some of the Cessna Citation on the larger side started being more frequent users, and lo and behold, the airport may need to extend the runway. So on to the next slide, if you would, Tom. Okay, and so one thing that was challenging for Watford City, to say the least, is they have a lot of site constraints. When the original master plan was being conducted in 2007, like I mentioned, they were just kind of working hard to keep their existing length, and the plan more or less, figured that, well, if you need to extend it in the future, a different site would be preferable due to the high costs and challenges with on-site. And so, now we fast forwarded to the Bakken boom, and we are looking to see if we can extend the runway on-site. And on the screen here, on the lower left, this is looking toward the south end of the runway, the 30 end. There's a pretty big hill off the side, or off the end of that really made some operational challenges for the existing runway, but it also made extending it nearly impossible. And on the right side of the screen, a high school was being developed in the upper right near the airport. There's a lot of infill for infrastructure, whether it's buildings, existing roads, or proposed roads. The two red lines on the bottom, that is the Watford City bypass and the frontage road just north of it that they're just finishing up construction on now. So, and that little arrow is pointing to that massive hill waiting out in the distance. So a lot of challenges to try to extend and expand on the existing site. So we kind of scratched our head and figured, well, maybe we do need to do a more in-depth alternative site analysis study. And next slide, if you would, Tom. So in 2015, that's what we worked on. Some of it was done from our desktops using GIS to kind of screen out some areas that obviously would not be workable. But a lot of it was spent just kind of driving around, looking to see if some of those areas where you had flat ground relatively flat ground that could accommodate the airport, it was that in close proximity to paved roads. Does it have any infrastructure that would limit or make it too costly to construct there? And it became obvious pretty quick that looking for developable space in the Watford City area is a tough challenge. I mean, most of the developable property was spoken for. We had a couple of promising sites, only to drive there and see new pipelines getting put in, or a gas plant in one instance. So it became obvious that there weren't any great sites within close enough distance to Watford City to be workable. So then we went back to the drawing board for the existing runway site again. And we had a lot of conversations with the state and the FAA as well, working with KLJ and the airport to figure out, with the constrained site, is there some wiggle room on certain design standards given those difficulties? And we kind of worked through that together to try to find a solution. And we did the planning and the environmental on a dual track to try to speed things up as well. So we've got an ALP update, an environmental assessment going on as we're trying to fine tune the best alternative. And if you want to go to the next slide, Tom. And so lo and behold, we found a workable solution, but there were definitely some challenges getting there. For example, the runway length that we wanted to achieve would be around 5,700 feet, 5,800 feet for Watford City circumstances. You know, their elevation, the gradient of what the runway would be, the typical temperatures for the hottest months of the summer. So that 5,700 feet, 5,800 feet we needed, we couldn't achieve that without having runway protection zones going over roadways. And RPZ policy has kind of fluctuated over the years. When earlier studies, it seemed like it might be acceptable to have roads in there if you can keep residences or businesses, that type of use out. But as we were going through it, the FAA policy became pretty black and white that for Watford City, for this new runway project, we could not have roads in the RPZ. So through that study, we ended up coming up with a solution that, if you want to go to the next slide, that involved using declared distances. So, you know, if I could, I would have a big caution sign that pops up here, but I don't. But more or less, you know, it's a decision that shouldn't be taken lightly to go this route. You know, using declared distances, it's something that it takes a while to understand the intricacies of that. A displaced threshold that reduces landing distance available, you know, that's one thing, because you have visual cues that make it a little easier for pilots and everybody else in the aviation community to understand. But what we had to do here for Watford City was more or less have, along with displaced thresholds for certain operations in certain directions, you had to be wheels up if you were taking off to the northwest, coming from the 30 end over there at the displaced threshold point, in order to clear the RPZ. You know, the approach RPZ and the departure RPZ for Watford City happen to be the same. So that's where you might, if you can see the lines on the screen, some of them stop at the threshold, some go all the way to the end. It depends on if you're landing or taking off, what pavement's available to you. But what we did was we broke it down by different direction, and we more or less got pilots and operators the length they need for any given operation. If you're taking off downhill, technically you might not need as much runway as if you're taking off uphill. So at the end of the day, we got it to work, just involved using declared distances, which also caused some ripple effect for design and other planning elements. You know, the hold lines, we had to move those further away than, you know, the typical distance you would have in order to keep hold lines outside of the approach surface. Line of sight requirements. Initially, when we were thinking it would be just your standard 5,700 foot runway, we might come back and do a full parallel taxiway in a subsequent phase. You know, we might have a quick turnarounds or partial parallels, but what we found for declared distances, there wasn't any budge room on where that displaced threshold was. You had to have 200 feet of level or down prior to that. So for the southeast end of the runway, that meant that there was an incline for the runway going up there, then level, and then back up again. And in order to be able to meet the line of sight requirements, where a pilot, you know, or somebody's eyesight 5 feet above the runway can see somebody else 5 feet above the runway, we wouldn't be able to do that the full length. And so in order to meet those for half the length, you would need a full parallel taxiway. So that ended up being part of the equation too here, that everything had to be done together for any of it to work. And so with the maybe not a sexy planning part out of the way, I can turn it back over to Shane, and he can take a deeper dive on some of the engineering.
Thanks, Matt. So when Matt, after all the planning and environmental, that was the hot mess that Matt left me with to put into play to design. So thanks, Matt, again for that gem. So going back, I guess, to the early part of the presentation when I talked about, you know, kind of the concept meeting and kind of what the stakeholders want out of a project. Well, these were the three that kind of out of that meeting for this project. So the owner was really looking for a new runway that was going to meet their operational needs. So since the oil boom, there had been some heavier aircraft that are using it, some jets that are coming in. They needed a runway that met their existing fleet, but then also looking forward to, okay, how, if oil comes back, natural gas expands, what are we really going to need? And are we setting ourselves up for the future instead of coming back in 10 years and having to do another overlay or what have you to meet sufficient strength? So meeting operational needs was first and foremost. Next was project costs. Obviously, money is pretty tight around North Dakota after the oil boom. So it wasn't the days of 2014 where you write a blank check and it can be cashed. The airport, along with the city and the county, had to tighten up their budgets, and along with the FAA and the state as well. So keeping an economic option in mind as we were going through design was a top priority for sure. And then lastly was closure time. So we knew going in that the airport was going to have to be closed for at least one summer. So in order to try to keep it to one summer or a minimum of months instead of years was also important. So these were the kind of the three things that we always went back to when we were considering our options for this project. If you want to go to the next slide, Tom. So first is funding, the the fun part of the project. Who's going to pay for it, right? So the FAA can pay for all of it, right? They're good for 90%. Well, not quite the case as with most projects, and especially with this project. So, but really, what the FAA was really good about is giving us kind of a good penciled in number right away that they felt that they could come to the table with, and that's kind of how we phased the project from design to land acquisition to environmental planning, and then now in construction, to kind of phasing it so that we could maximize the most federal dollars. And then obviously with the state, kudos to Kyle Warner and his staff. They really stepped up to fill a big stopgap, not only with the final construction cost numbers, but really getting it from final airport layout plan to design. There was, as Matt went over, there was a number of studies that kind of added in, or that popped up, that wouldn't have been able to either be funded through the FAA, or we would have had to wait till the next grant cycle to do. So for Kyle and his staff to jump in, hey, yeah, we can fund a portion of that study in order to keep this thing moving was huge. And in my opinion, that really what made the project get to where we're at today. And going to working with the city, Luke Taylor, the airport manager, Kent Norbeck, the chairman, they did a fantastic job with their finances, getting their books in order, and then also working with the city and the county. The airport wasn't going to be able to fund the local share on their own, so them leveraging the county and the city and doing that early on was huge. And I would assume if we ask Luke and Kent those questions, that early engagement with those two local entities was huge. And we were fortunate, and the airport was fortunate, in that both the city and the county are huge proponents of the airport. They saw the limitations of the current infrastructure and the potential that could be with a new infrastructure in place. So having everybody on the same page was really huge, and really funding while it was, it was tough coming up with those final numbers. It really never got to the bloodbath that we were kind of anticipating going into construction. So if you want to go to the next slide, Tom, we'll kind of get into just a couple of the design elements that were kind of challenging, that were kind of unique for the project. So the first is, as Matt mentioned, with the runway profile, we had some terrain constraints where the elevation going from north to south, or on the slide here from left to right, went up at about a 2% slope. So trying to work with that and keeping that as much as that ground as similar as possible to reduce earthwork was big. So as you can see on the bottom of the slide here, it's kind of a heat map where the red areas are cut areas, and then the green areas are fill. So with the design and really one of the more challenging designs, as I mentioned earlier, was kind of tying everything in together. So after we took a look and set the runway profile, added in the pavements, okay, how are we going to build this thing? So after getting kind of the preliminary surface model completed, obviously we ran the hydrology and found out we needed 3 detention ponds for the site in order to meet the runoff requirements of the city, and then also to meet the 48-hour requirement for the FAA, and making sure the surface water was leaving airport property. So tying those in tying into the existing city infrastructure that they had just built within the last 5 years, a runway profile, our cultural constraints, wetlands, and just putting it all together. It was really cutting hairs there for a while. So then oh, by the way, with the earthwork, we're looking at almost 800,000 cubic yards of material that we had to move. So in working with that, and kind of the going back to the first operational points that the airport was concerned about, is how can we use that to figure out what do we do with all this extra earthwork, and how do we maximize that. So kind of going back to with what Tom mentioned about Bismarck, we didn't, there was a high water table on the north end of the runway. So when we looked at and poor soils, when we did technical investigation, there's very, very poor soil, some of the lowest CBRs I've seen, in fact, but it wasn't consistent throughout the site. So it was some spots were really bad, some spots were okay. We also had some spots that had a really high water table, and some that it wasn't an issue. So when we looked at the chemical stabilization of blending in lime or cement versus the mechanical stabilization, the recommendation of the geotech engineer, and what we ended up going with was the mechanical stabilization route, where when we got to those soft areas, we did an additional 2 feet of subcut. We put down a layer of geogrid, and then fill in with some of the material in the cut area. So we were going to have plenty of cut area. So then that way, kind of 2 things is expedite the construction a little bit faster, plus give us a little bit more uniform subgrade section throughout the whole runway, that we weren't building on one area bad, one area good, one area bad. That way it was kind of made it uniform, so it should reflect and give us a good product at the end. Another thing, going back to the dirt, so 800,000 cubic yards, that meant that we had roughly 400,000 to 500,000 yards of waste that we had to get rid of. So holy cow, all that, what are we going to do, and where are we going to put that? So we were able to waste a lot of it in actual future infrastructure areas. So the future apron, taxiway kind of development areas, we were able to waste a lot of the dirt in those areas. So kind of killing 2 birds with 1 stone with that. We were able to get rid of a lot of the waste, and we were getting rid of that waste in key areas that were going to be pivotal moving forward for the airport in the future, so they don't have to worry as much about the earthwork portion of those projects when it comes to be. Another aspect was the avoiding cultural sensitive areas and wetlands. So, and going back to the environmental, just when we thought we had the preferred alternative locked down early in 2017, we had kind of the surprise of some wetlands and some cultural sensitive areas. So we had to work around those. And then moving forward in the construction, there was the question, were we going to get into one of those areas again? So one thing with the pavement strength is that the justified pavement section was 6 inches of concrete on top of 6 inches of P209. And and really looking forward into the future, kind of going back to what the airport wanted, is to be set up for the future, so that in 10 years, if the aircraft were using the airport that they projected and that local businesses were saying they were going to be coming in or they would be utilizing, we didn't want to be short. So what we ended up doing is bidding 2 sections, 8-inch concrete section and a 6-inch concrete section. And then that way, the FAA would be able to pay for up to the 6-inch amount, and then that way we had that hard cost difference for what was above and beyond, and that ended up working out pretty well. So the airport did, in fact, go forward with the 8-inch section, so which was plenty of overkill to a lot of people, but looking at the fleet projections and the comfort level with the city, the county, and the airport authority, that was going to be kind of the best bang for the buck moving forward. Go to the next slide, Tom. So one of the other things we had to consider was the phasing of the project. So do we do this thing in 1 year, or do we do this in 2 years? So kind of the initial push originally was to do the project in 1 year, just rip the Band-Aid off, get it all done and get it over with. We have all the costs in the 1 year, and get it taken care of. There's a couple things that were going to be a challenge with doing that in 1 year. One is that the airport would be closed for sure from an April to November time frame, which was the most closure time, which the airport wasn't in positive for, so because they wanted the least amount of closure time that they could. Another risk of doing it in 1 year is that the contractor would have to build risk into their cost for that project, just in case it didn't get completed, whether it be weather or something else comes up. So we anticipated a little bit higher costs. And in talking to a few of the larger contractors that would be interested in, they noted as such that would be risk that they would have to build into the project. And the other, and probably the most significant thing, was that going into is with the discovery of some cultural sensitive areas. Once we got it into this thing, and once we got into those deep cut areas, what were we going to find? And if we were going to find something, especially if it was significant, getting it done in 1 year would probably pretty much make it impossible. So when we really looked into it, 1 year was going to be a stretch. Really, to say that all the stars had to align would be an understatement. So when we looked at the 2-year construction, some of the things that stood out about that is that we could do the first year of construction with the airport remaining open. So the airport would only have to be closed the second year of construction in a shorter time frame. So instead of April to November, we were figuring in April to September, maybe October. So roughly 2 months shorter overall closure time for the airport. The second thing was that it did allow additional time for if anything came up as far as bad weather, the first year, or the cultural findings. If there was something, it would allow a little bit of flexibility for us to do that. So with all that being said, we did end up moving forward with the 2-year construction, and that's what you see on the slide right now. So in 2020, everything was completed. That's shown on the slide there. So what we achieved was the construction of all 3 detention ponds, all the grading outside the current runway safety areas, the taxiway safety areas, and we were able to get the 2 ends of the new runway fully constructed and paved. So lo and behold, in 2020, kind of our worst fear came to fruition, where there was a cultural find in one of the cut areas. And looking back, I mean, it's a saving grace that we did do the 2 years, because with the delay in that, and kudos to the FAA and Sherry Lars for coordinating that effort. It was a big undertaking. and just looking at, from the consultant side, we were just kind of informed and working with the FAA and the tribes for different coming up with different cost estimates. But really for the FAA and for Sherry to coordinate that, it was a big undertaking. So to have that happen, and only for the runway or for the airport to be closed for 1 year, it would have been pretty daunting. I think there would have been a lot less sleepless nights than there already were. So looking back, so hindsight being 2020, of course, I think everybody involved is pretty glad that we end up going with the 2-year construction phase. So then for finishing up for this year on the right side, essentially all the pavements in green are what we have to complete. So essentially everything on the outside the safety areas was completed. So essentially we're filling in the rest of the runway and the taxiway. I'm going to go to the next slide, Tom. Okay, and then where we're sitting at today. So the left-hand picture. So that's was taken in September of 2020. So essentially that's where everything was pretty much buttoned up, and we actually the contractor finished on time. So that's something that usually doesn't happen on the airport projects, is contractors finishing on time. So the paving was completed on both ends, as you can see there, and a lot of the grading was completed. So really going into next year, once we rip up the existing runway and we get into the existing subgrading, connect those two pieces, is hopefully we'll have everything finished up. And we're looking at overall construction schedule to be substantial completion is September 15th of this year. And then the approaches for both runway ends are scheduled to be implemented October 7th of this year. So knock on wood, and hopefully all the stars continue to align. But we're on good track to get this project finished up on time and at or under budget. So again, kind of a rarity of the project this size. So. That's about that all I had. Anything else, I guess, Matt, that I missed that you wanted to add?
No, I don't think so.
All right. Give me 1 second. I gotta pull it up here. You did have a question come in.
Okay.
Sorry. All right. It says, "Am I understanding this correctly? Does this proposal use threshold areas paved the same as the usable runway, rather than being soft paved or crushable safety zones?"
Yes, that is correct. Yep, the whole the stretch of the runway is the same pavement section.
Alright, that was all the questions I had, guys.
All right. Well, if there's no more questions, we just collectively want to thank you for this opportunity to give you a little presentation on some of our thoughts related to these important topics, and have a great day.
Yep. Thanks, everybody.
You-